Good afternoon, students. Now we will see the last portion of chromatography, that is applications of chromatography. So in last class we discussed about the chromatographic process. Now what are its application, where it is used actually. So as we know that chromatography is used to separate colors in a dye, any type of dye, and can also be used for the separation of ink dyes. Different types of ink dyes contains different color components, so those color components can be separated by the process of chromatography. Now it is also used to differentiate coloring agent used in food products. As you know that nowadays many colors are put on the food to make the food or vegetables or other food items attractive, and to show the originality they generally put the color on it. So to differentiate what are the coloring agent used in those food items, we can just separate those coloring agent by the process of chromatography. Now it is also used to isolate plant pigments from root and leaves. If this contains any pigments, so that pigment can be separated by doing the chromatographic process. From that we can just isolate the pigments present in root or leaves. Then it is also used to separate mixtures of drugs. Okay, if you have a mixture of drugs and you want to separate it out, those drugs from the mixture, then that also can be done by using chromatography process. Now separation of carbohydrate, vitamins and amino acids also can be separated out, can be done by using chromatographic process. So there is a use application of chromatographic process here. You can just note it down, the applications. Now we will see the next separation, that is separation of mixture of two or more miscible liquids. Okay, so to separate the mixtures of two or more miscible liquids, we use distillation process. So students, you would be knowing what do you mean by the miscible liquids? Miscible liquids are the liquids which are soluble with each other. So those miscible liquid mixtures can be separated by different distillation processes. Now what is the definition of simple distillation process? So distillation process or simple distillation process is a process which is used to separate mixture containing two miscible liquids, okay, that boils without decomposition and sufficient differences in their boiling points, that is above 25 degrees Celsius. So as per the definition of distillation, there are actually three criteria given for the mixture to undergo the distillation process. So what are the three criteria as per our definition? The first criteria is that whatever the mixture contains liquid in it, miscible liquid, it should be a miscible liquid. Okay, second criteria is the liquids present in the mixture should have differences in their boiling point, that is above 25 degrees Celsius. With example, we will just understand. If we have mixture of two immiscible liquid, that is acetone and water. So if we see the boiling point of acetone, it is 56 degrees Celsius, and the boiling point of water, you know that it is 100 degrees Celsius. So what are the differences in the boiling point of acetone and water? It is about 44 degrees Celsius. Means the differences in the boiling point between acetone and water is above 25 degrees Celsius. So this type of miscible liquids whose boiling differences in their boiling points is above 25 degrees Celsius, so that type of miscible liquid mixture can only be separated by the distillation process. This is the second criteria. Third criteria is whatever the liquids, miscible liquids which are present in the mixture, these liquids can not undergo decomposition process on heating. That means what? When acetone and water are getting heated, they should not change their chemical composition during heating. So those type of only the liquid miscible liquid mixture can be separated by the distillation process. So I repeat all the three criterias as per the definition of distillation process. First, the mixture containing the liquid should be miscible with each other. Second, the liquid should have differences in their boiling point, that is above 25°C. Third criteria is that the liquid present in the mixture should not decompose on heating or should not change their chemical composition on heating. So those type of miscible liquids only present in the mixture can be hence separated by the distillation process. Okay, we can have some different examples also. First I told you the mixture of acetone and water. Then you can have the mixture of methanol and water. Methanol and water are miscible liquid. They are soluble with each other, and if we see the boiling points, then methanol boiling point is 65°C and water, you know, it is 100°C. So differences is again more than 25°C. So hence this mixture also can be separated by distillation process. And you can have other example like benzene plus aniline mixture. Okay, so we'll just first briefly we'll understand what happens in distillation process through this flow diagram. So if we say a mixture of miscible liquid, that is acetone and water, and we'll start heating it up, then when we start heating the mixture and when we see the temperature comes to 56°C, then all the acetone liquid, it starts boiling and it starts vaporizing. Okay, as you know that boiling point of acetone is 56°C. So acetone starts boiling first, then water, and it starts vaporizing also first. So when acetone starts vaporizing, it goes upward and enters into the condenser chamber, water condenser chamber. There all the vapors of the acetone get cooled down and converts into the liquid, and those liquid hence can be collected through the condenser in a beaker. So in this way we can see that the low boiling point liquid can be made to vaporize and hence can be collected and separated in a beaker, and water will still be there only in the distillation flask. So in this way it is just a simple distillation process where we use this process to separate the mixture of two miscible liquids only. Okay, in simple distillation we can separate only the two miscible liquids from each other. Okay, so we will see the setup. Before we'll see the apparatus used for the distillation process. So you can see here, this is a distillation flask in which we take this mixture of acetone and water, and this is the flask where we heat the mixture. Since it is round in shape, that is why it is also called as round bottom flask. Okay, so you can see here the protrusion. So this can be fixed to this tube. This is called what? Condenser tube, and it is fixed to this tube through a cork here. So this is called as the water condenser. Water condenser where the vapor of the acetone liquid will come through this way and it will get condensed here in this water condenser tube and converts itself into liquid state. So we can see here an inlet and outlet in the condenser tube. So we connect this inlet, okay, by tap water through a pipe and provide continuous supply of water to this tube. So you can see this is the inner tube, and the inner tube is surrounded by this outer tube, where the inner tube is getting continuous supply of water on its surface, on its outer wall. So water is continuously flowing in and flowing out through water outlet and keeping this inner tube cooled. Okay, so we will see now. We have taken the distillation flask and it is fixed through a iron stand here, okay, and it is again closed with a cork, and one thermometer is put inside the distillation flask to watch the temperature rise. Now you can see that this distillation flask is fixed with the condenser tube, as I showed you now, this condenser tube through a cork. Okay, and we can see this is the inlet of the condenser chamber and this is the outlet of the condenser chamber. So inlet of the condenser chamber is fitted with the tap water through a pipe where continuous supply of water will be provided in the chamber, and this is the outlet. Water is flowing in and then flowing out through this, flowing in and flowing out this outlet. Okay, and the mouth of the condenser tube is then over a beaker where whatever the liquid acetone will drip, it will get collected in the beaker. Okay, so we will take the mixture here in distillation flask and we will start heating it through the burner. When the temperature reaches to 56 degrees Celsius, then whatever the acetone present in this mixture of acetone and water start vaporizing and goes to the upward, and soon they enter into the condenser chamber. When they all the vapors of the acetone enters the condenser chamber, because the tube is getting continuous supply of water on its surface, so that inner tube is cooled actually. So water the vapors comes in this tube also start getting cooled and condensed and converts into liquid state, and we can see now what is the acetone vapor are there, they just convert into the liquid acetone which can be then collected into the beaker. So in this way we can separate the acetone from water. So here you can see that water is still there. One should be very careful that when we see that all the acetone got vaporized and converted into the liquid state and got collected in the beaker, then we should just switch off the burner. We should not let the water boil. Before that only we have to switch the burner. Okay, so this is about the simple distillation process for separating two miscible liquid mixtures. Okay, now next process is fractional distillation. So fractional distillation is the special type of distillation process, and if we see the definition, this process is used to separate mixture of two or more miscible liquids whose differences in their boiling point is less than 25 degrees Celsius. Hence we can say that fractional distillation process is very much different from the simple distillation process. There are many differences between fractional distillation and simple distillation process. So first difference is that in simple distillation we could separate only two miscible liquid mixture, where in fractional distillation we can separate two or more miscible liquids from a mixture. Second difference is that in simple distillation the liquids contained in the mixture should have differences in their boiling point more than 25 degrees Celsius. But in fractional distillation, whatever the miscible liquids are there in the mixture should have differences in their boiling point less than 25 degrees Celsius. That means what? In simple distillation, we cannot separate those liquid mixtures whose boiling points are very close to each other, that is less than 25 degree Celsius. For example, if we take the mixture of acetone and methanol, and if we see the boiling point of acetone, it is 56 degrees Celsius, and boiling point of methanol is 65 degrees Celsius, and if we see the difference in the boiling point between them, it is about 9 degrees Celsius. So we can just say that boiling points are very close to each other. So this type of mixture we could not separate, liquid mixture we could not separate out from simple distillation, because as per definition of simple distillation, only those liquid mixtures can be separated whose difference in boiling point is more than 25 degrees Celsius. And here you can see that boiling points are very close to each other. So this type of liquid mixture can be separated only by the fractional distillation process. Now, the most important difference between simple distillation and fractional distillation is that in fractional distillation we use fractionating chamber for the separation. That is why this type of distillation process is called as fractional distillation process. We can have several examples for the liquid mixture which can be separated by fractional distillation. As I told you, first is the mixture of acetone and methanol. Second, the petroleum products. So you know that petroleum contains many things soluble in it, like petrol, gasoline, naphtha, kerosene, diesel. Then you have lubricating oil, fuel oil, and many residual oil in it. So those can be separated only by the fractional distillation process. And third is the mixture of air. You know that air is the mixture of various gases like nitrogen, oxygen, carbon dioxide, argon, etc. So those mixture of gases, those gases in the mixture of air can be separated by fractional distillation process. So in fractional distillation, you have different type of setup. That is for separating the mixture of acetone and methanol. Fractional distillation setup is little different from the fractional distillation process used for separating the petroleum products, and also for separating the mixture of air from fractional distillation. You have the fractional distillation setup little different. So you could just expect different setup of fractional distillation. So students, we know that we use fractionating chamber in the fractional distillation process. Now, why do we use fractionating chamber in fractional distillation process? So as we know that when we heat the reaction mixture here containing the miscible liquids in it, the liquid starts boiling and it moves, the vapor of the liquids moves towards upward. But the vapors are not able to move easily towards upward because the distillation flask is fixed with a fractionating chamber, and fractionating chamber is made in such a way that vapor do not move easily towards the upward. That means we have made the fractionating chamber in such a manner that certain hurdles or obstacles are put inside the fractionating chamber. For example, in this fractionating chamber, we have placed certain grass beads as an obstacle and hurdle so that whatever vapors coming upward should not move so easily towards upward. Okay, so you can expect different type of fractionating chamber, like this is also one fractionating chamber, this is also one fractionating chamber. You can see here different bridges have been made as an hurdle or as an obstacle. Here also you can see the setup is like that. So we will just see one example and we'll see what happens in the fractional distillation process. So you can see here we have taken one distillation flask which is fixed with a fractionating chamber through one cork. To this fractionating chamber, we have put one thermometer to just watch and maintain the temperature of the system. And to this fractionating chamber, we have again fixed one water condenser through the cork. And to the mouth of the condenser, we have put one beaker to collect the liquid separated. Now, in distillation flask, we have the mixture of acetone and methanol, whose differences in their boiling point is very less, that is about 9 degrees Celsius. If you could see the boiling points of both the liquids are very close to each other. So, when we start heating the system, we should be very careful that we should maintain the temperature here at this place near the outlet of the fractionating chamber to 56 degrees Celsius, which is the boiling point of acetone, so that all the acetone liquid rises here as a vapor. Okay, so we have to maintain here the temperature, that is to 56 degrees Celsius, and accordingly we have to maintain the temperature here also. So if here the temperature is maintained at 56 degrees Celsius, here you could expect the temperature of the system in distillation flask at a point 70 degrees Celsius, and you could expect both the acetone and methanol liquid starts boiling and converting into vapor and rise towards upward, because both boiling points 56 degree and 65 degrees Celsius, they boils at those temperature, and because the temperature here is 70 degrees Celsius, so both the liquid start vaporizing and rising upward. Now as they rise upward, obviously the temperature lowers, because we could not expect the temperature here as same, that is at 70 degrees Celsius. We could expect the temperature here as 65, here as 60, and here it is 56 degrees Celsius. As I told you, we have to maintain here at 56 degrees Celsius. So when both the acetone and methanol vapors rises upward together, and the temperature gets lower as they move upward. So at this level where we can expect the temperature lowers to 60 degrees Celsius, so all the methanol vapor starts condensing and falling into the reaction mixture, because the boiling point of methanol is 65 degrees Celsius, and here the methanol is not getting the enough temperature, that is not getting 65 degrees Celsius to be in its vapor state, because the temperature here is about 60 degrees Celsius. So whatever the methanol vapors are there, they start cooling down and falling into the reaction mixture. But the vapors of acetones are still passing through this hurdle, because temperature here is 60 degrees Celsius and acetone boiling point is 56 degrees Celsius. So acetone are still in vapor state and they are passing this vapor and rising towards upward. At this point, when the temperature is 56 degrees Celsius, so all the acetone vapors falls into this tube, that is outlet, and goes to the condenser tube. In the condenser chamber, where the continuous supply of water is provided, so whatever the hot vapors of the acetone enter into this inner tube of the condenser, they got cooled down, condensed, and converts into liquid state and can be collected in a beaker. When we see that no vapor is passing through the chamber now, that means all the acetone has got converted into liquid and got collected in the beaker. So we can just took it off this beaker away, and next time we start rising the temperature to 65 degrees Celsius. That is, we have to maintain here temperature now at 65 degrees Celsius, so that whatever the methanol liquid is there in the distillation flask, it gets again vaporizing easily, pass through this hurdle, as the temperature maintained till here is 65 degrees Celsius, goes to the condenser tube, liquefy, and can be collected in another beaker. So in this way, in fractional distillation process, you should be very careful with the temperature maintenance. So here also we can see the liquid having lower boiling point vaporize first and can be collected first. That is, acetone is collected first and afterwards methanol is collected later. So this is about the fractional distillation process. Now we will discuss the homework questions that was given to you in the previous class. So we will see one by one. The questions given were very easy. So we'll see. Just first question is, what do you observe on the filter paper as the water rises on it in the paper chromatography? So what did we observe? We could see the different color components of the ink got separated out on the filter paper strips as the water rises on it in the paper chromatography. So as you could see in the paper chromatography process, on the filter paper strip, you can see different color component spots. Okay. Now second is, do you obtain color on the filter paper strip? Yes, obviously we obtain different color spots on the filter papers, different color components. You could see red, blue, green and all. Third question is, what according to you can be the reason for the rise of colored spot on the paper strip? So there we got to know that due to the solubility of this color component in water or in mobile phase, the highly soluble colored component rises at the faster rate along with the mobile phase, that is along with the water through the filter paper strip, and then the less soluble component later on. So whatever the most soluble component in mobile phase rises at the faster rate, and you can see the spot at the top, and then later on the different other component which are less soluble in the mobile phase. Okay. Now fourth is, suggest separation techniques or techniques one would need to employ to separate the following mixtures. So some of you have not written properly, many of you have written wrong also. So you should be very careful. You should understand so many processes, separation processes till now we have discussed. You have to just see which mixture is meant for which separation method. Okay. So first I see mercury and water tha aapka. Mercury and water. So you know that mercury and water, these are the liquids which are called immiscible liquids. So you know that immiscible liquid can be separated by using separating funnel. So in separating funnel, what is happening? Decantation process is happening, no? Where the heavier liquid goes at the lower level, and the liquid having lower density or lighter liquid floats over the heavier or the high density liquid. You know that. So in decantation process, it's like that only. So you can just write in mercury and water, the separation is by decantation process using the separating funnel. This much is just enough. Okay. Now second is how to separate potassium chloride, it is KCl, and ammonium chloride, that is AlCl3. So you know that out of this ammonium chloride is sublime substance. So you know to separate any sublime substance from any non-sublime substance, you just have to use the sublimation process. So you have just to write the sublimation. By sublimation process, you can just separate it out ammonium chloride, okay, from the China disc. The third one is common salt, which is NaCl, sodium chloride, water and sand. So if this mixture contains these three substances in it, in which NaCl is a solid, and when it is mixed in water means it got dissolved in water, and it would have formed a what salt solution, and plus sand is insoluble in it. So sand is very much heavier, so that can be first separated out from the sodium chloride water solution, salt solution, because here salt and water have made the solution, and sand is distinct layer or distinct substance in the mixture. So it can be first, sand can be first decanted, so it can be separated by decantation or filtration process. Okay, so sand can be just separated out from decantation or filtration process from the salt solution. And then from the salt solution, how can you separate salt from water? By evaporation technique. So after you just separate sand from salt solution, you can undergo the evaporation process to separate salt from water. Very easy. Okay, understand. So D is kerosene oil, water and salt. Here also when you have mixture of kerosene oil, water and salt, so here also water and salt means you would have made the salt solution, and kerosene oil which is insoluble in the salt solution. So here you can get the two immiscible liquids, that is salt solution and kerosene oil. So that can be done by using decantation process, by using separating funnel. So first what we should do, we should separate out the kerosene oil from the salt solution by using decantation process, by making use of what? Separating funnel. Okay, now we are left with the salt solution. So salt solution, in salt solution salt can be separated from water using evaporation method. Okay, so next method what we can employ, evaporation method for separating salt from water. So whatever questions I give you, that was very easy. So if you have done any mistake or till now if you have not submitted your assignment, so you can just note it down all the answers and understand it. Okay, thank you.